Welcome to the Philosopher's Abyss. In this second edition, we'll be talking about the scientific method. You may be asking, what is the scientific method? The American Heritage Dictionary's definition is on screen. In simple terms, though, the scientific method is the system scientists use to test for truth. While not all sources agree on the exact steps, the essentials of the scientific method are as follows. First, observe and research. Before we can begin, we need to choose a specific topic. As an example, let's pop a balloon. This is a simple topic that probably doesn't require any outside research, but in general, you should familiarize yourself with the topic you plan to work with. Second, pose a question. Our question will be, what is one way that I can pop a balloon? Third, form a hypothesis. We can speculate, using our own knowledge or information gathered while we were researching our topic, a possible answer to the question. For example, if we put more and more air into our balloon, the pressure will eventually be too much for the expanding rubber, and the balloon will pop. Fourth, develop an experiment to test the hypothesis. By taking an actual balloon and filling it with air, we can see whether or not the balloon does indeed eventually pop. Fifth, conduct the experiment. Science is about facts. It is essential that we test our ideas in the real world. Without an actual, physical testing, it isn't science. Sixth, accept or reject the hypothesis. Using information generated by the experiment, we can say that the hypothesis is supported by our experiment or that the hypothesis is wrong. If our balloon didn't pop when we filled it with an ever-increasing amount of air, we would know that our hypothesis was incorrect. Of course, our balloon did pop. That doesn't mean our hypothesis was necessarily correct. The balloon might have popped for some other reason, but we can now say that the hypothesis is supported by our experiment. Here is a visual representation of the scientific method, shamelessly stolen from howthingswork.com. Notice how the bottom is cyclical. If the experiment disproves your hypothesis, you create another hypothesis, then test it. Even if your hypothesis is supported by your experiment, it is essential to retest it whenever new information becomes available. As I once heard Michael Shermer say, science has built-in self-correction. So, why is the scientific method important? Perhaps most importantly, it demonstrates some elements that are absolutely essential to the very idea of scientific investigation. That the only things we can know with certainty are things that we can test, and that even a validated hypothesis is not the same as truth with a capital T. Science tells us that an idea is or is not supported by well-known facts. Even a hypothesis that is very well supported may be disproven by our next experiment. Science always seeks the truth, but never claims that its truth is absolute. In science, the only certainty is uncertainty. The investigation of truth is an ongoing process. Unlike religion, which proclaims some static, unchangeable ultimate truth, science is not only willing, but obligated to constantly adjust and refine its perception of reality. In a more practical sense, following the scientific method helps to insulate us from human error. It is easy to get carried away with conjecture. One can arrive at an incorrect conclusion, even when following a logical thought process. By forcing us to always test our ideas before accepting them, the scientific method ensures that what we believe to be true is based on facts and can be independently verified. Of course, the scientific method is essential in the lab, but more broadly, it should be of interest to anyone who wants to thoroughly explore the reality around them. The elemental principles of testability and critical analysis are essential to any rigorous pursuit of truth, whether you're formulating a grand philosophy or just trying to understand the day-to-day happenings in your own life. Thanks for tuning in to the Philosopher's Abyss. Hopefully you found it somewhat informative.